All right, the mean value theorem is, you're going to see some things that look kind of like extreme value theorem and some things that are different. But first of all, when you see this word mean, in math, what does mean mean?
Average.
Average, okay. This is not as simple as saying the average of the values or anything like that. However, the word average is going to come up, and I'll remind you about that. And that'll be a way maybe you can remember that this is the mean value theorem. All right, so just like the extreme value theorem, there are some prerequisites. First of all, f has to be continuous. That was the same as the extreme value theorem. All right, also we have to have a closed interval. Okay, both of these we had to have that in order to do extreme value theorem yesterday. Okay, so it's the same too. But we also have this other one that says that the function has to be differentiable. So I want you to think for a second. What are some continuous functions that are not differentiable? Or what are some attributes? A cusp. Okay, so there can be no cusp. I heard holes. The reason holes don't answer my question because holes make something not continuous. So what I'm looking for is something that is continuous and not differentiable. All right, we want both. So what you're really going to have to look for here is no cusp. If you want to say no holes, it really kind of goes underneath here. Yes.
If there's like a hole at the absolute maximum, would that be considered non-continuous?
Correct. If there's a hole anywhere, it's not continuous. So here we don't want any cusps, and we don't want any vertical tangents. Okay, vertical tangents are where the graph is almost vertical. All right. I do want you to notice that this says the open interval. What this means really is that it's okay if there's a vertical tangent on the endpoint itself, but it just can't happen in the middle of the graph. Okay, so this right here is actually not going to be a problem. This cusp thing, though, definitely could be a problem. All right, so these have to be true in order for us to even use mean value theorem, and so let's get to what this actually means. Okay, first of all, f prime of c. What does f prime mean? The derivative, right? And what is the derivative? Slope of the tangent line, okay? So let's write that over here. Slope, and that's of the tangent line. How many points are associated with the tangent line? 1 point. So see how there's just one c there. All right, as opposed to this f of b minus f of a all over b minus a. Okay, that's pretty wordy, but when else have we seen something minus something over something minus something? Just regular old slope. How about y2 minus y1 over x2 minus x1? Okay, how many points are we talking about here? 2, right? And x, there's 4 values because there's an x and a y value for each point. Okay, this is slope of the secant line. This is slope of the secant line, and it requires 2 points. So what mean value theorem says, if we have all of these prerequisites, if f is continuous on a closed interval and differentiable on an open interval, then there exists a number c so that the slope of the tangent line is equal to the slope of the secant line somewhere. Okay? Basically what they're telling you here is that our tangent line is going to be parallel to our secant line somewhere. Okay? Does this sound familiar to y'all? Yeah, on your after party you did this. Okay, I'm the one that's due tomorrow. You've seen this. And so if you haven't started on that yet, then after today you should be totally good to go on the front. All right, so example 1, draw the secant line to the graph through these points. So let me explain what these mean, because these could be confusing to you. A is obviously the x value. The y value then, if we're talking about f of x, is just f of a. So f of a is just your y value. You could almost consider it like this. x1, y, whoops, I didn't mean to do that. Bring back that. Okay, x1, y1, and then this would be x2, y2. And so here we put f of b right over here. And if I connect these two, the line looks like that. Is this a tangent line or a secant line? It's a secant. Secant means goes through the curve. Okay? So I'm going to go over here and I'm going to write m, and I'm going to write a subscript secant so that we know that this means the slope of the secant line. All right, now I don't have any numbers here, but anytime you're trying to find slope of a line and you know the 2 points, you just use slope formula. So it would be y minus y, or y2 minus y1 if you want to think of it that way, f of b minus f of a, and then over the x's subtracted. So does this look familiar right here? Yeah, we just saw it right up here. Okay, it's the same thing. All right. So we did that, and then it says, then sketch any tangent lines guaranteed by the mean value theorem. Okay, so first, let's make sure we can even use mean value theorem. Is this function continuous?
Yes.
Yes. Do we have a closed interval?
Yes.
Yes. Is this function differentiable everywhere between a and b?
Yes.
Yes. I want to be clear here. This function is actually not differentiable exactly at b. Why not? Vertical tangent. But we said this, if you kind of just read above there, it doesn't matter if it's differentiable at the endpoints, it just has to be differentiable everywhere in between it. Okay, so this line has a particular slope, negative, small. If you put your pencil on top of that line and you roll your pencil up, keeping the slope the same, this is the only downside of using a computer. Okay, if I take this line and I want to move it to where it's only touching the graph in one place, what type of line is that? This is our tangent line. Can you tell me the relationship between the tangent and the secant line? They're parallel, right? These two lines are parallel, therefore they have the same slope. Okay, is there another tangent line?
Yes.
Okay, so if we were to bring our line down, it would look about like right there. Okay, so if I wanted to find the slope of the tangent line, well, I know these two are going to be equal, but this is where you have to do the derivative. Okay, and not only that, you have to do the derivative at a specific point. Okay, since I have two, I'm going to label these C1 and C2. There could be 3, there could be 4, there could be just 1. All right, but there is going to be at least one. This is what the mean value theorem tells us. There's going to be at least one tangent line that has the same slope as the secant line. Okay, that's all it really is saying. We're going to do theorem write-ups over this later, and so today I really want you to get going, and then we're going to kind of come back and revisit it and do the theorem write-up as a review. All right, so these two things are the same. Before I move on, is there anybody that feels like this tangent line might eventually cross this graph and that might make it not a tangent line? Are any of you thinking that?
Yes.
Okay, so you're right. That wouldn't make it a tangent line. But I just want to remind you that in our world, when we're doing mean value theorem, we're only looking from A to B, which means that everything outside of A to B doesn't exist. It doesn't matter. You can kind of almost think about it like this. Remember how we did relative maxes and mins? Okay, think of it like a relative tangent line. It's a tangent line just relative to this area. Okay, so if you were like, I wasn't wondering about that tangent line eventually crossing, well, you're good too. Okay. Does anybody have any questions before I move on? Mm-hmm.
Does it does the tangent line always occur at roughly the relative minimum maximum?
They've got to occur somewhere where the graph is changing, and so his question was, do they always occur at maxes and mins? So I can change it to where that might not happen. All right, but that's a great question, and we're going to kind of explore this a little bit more. And on a polynomial graph, it seems like the answer to that might be yes. But we know not all graphs are polynomials. So here we have one right here. This graph doesn't really even have a maximum. And so that kind of throws that off. All right. So example 2, it says apply the mean value theorem. This means that if you can find the answer just by using logic, great. You won't get the points unless you show mean value theorem. That's why there's all this space over here. And I say that because some of you are going to figure out what the answer is without really doing a whole lot of work. And that's good. That means you're going to know when you get the right answer. So we have this function. It's a rational function, and it's on the interval 1 to 4. Okay, so what I want you to do is go down here to the graph, and let's block off this graph 1 to 4. The only part of this graph I care about is from 1 to 4. I don't care about anything else. Okay, the reason this is important is because, okay, there's a vertical asymptote on this function. All right, but it's not occurring between 1 and 4, so I don't care about it. All right, between 1 and 4, I have continuity, I have differentiability, I have a closed interval, everything's good. Okay, I can use mean value theorem. All right, so first, let's find the slope of the secant line. Don't make this harder than it needs to be. What's the slope of the secant line? 1, right? Up 1 over 1, up 1 over 1, up 1 over 1, up 3 over 3, whatever. Okay. On another problem, you might actually have to get down and do some of this right here. You might have to do that work. Okay. On this problem, we really didn't have to worry about it. Okay. If you didn't recognize that, you would be doing something like this: 4 minus 1 over 4 minus 1. Okay, that equals 3 over 3, and that equals 1. Okay. Either way, the slope of the secant line is 1. All right. Now we've got to compare that to the derivative. All right, so that means we've got to find the derivative. All right, we practice derivatives for an entire unit. What's something you could do to this to make derivative easier?
Minus 4x to the negative 1.
Yeah, make it look like a polynomial. Because otherwise we're going to have to do quotient rule. Why do quotient rule if you don't have to? Okay, so what is the derivative? 4x to the negative 2 power, which is the same, excuse me, as 4 over x squared. Now, I don't really feel like you need to simplify all the time, but you're going to see why it's definitely going to help us to know that this is 4 over x squared. Okay, so now remember the derivative. This is the slope of the tangent line, okay? So 4 over x squared represents all the slopes of all the tangent lines to this graph, okay? Because that's constantly changing. The steepness of this graph is changing, the slope's changing. And what I want to know is, where is this the same as 1? All right, before I continue, anybody think they know the answer just by looking at the graph? Where is a tangent line have the same slope? And I'm looking for the x value. 2. And you would be right. Okay, so it's good to know what you're looking for. We've still got to show it. Okay, what we need to show here is these two things being equal and solve for x. So I'm going to let 4 over x squared equal 1. Okay, what would I do next to solve this? Okay, you can even almost think of it like cross multiply. I would get x squared equals 4, and technically x would equal plus minus 2. But c can equal plus minus 2. It can only equal 2. Why?
Because we're only looking between A and B.
You have to be between 1 and 4. So I can't say that c is equal to 2 and negative 2. It doesn't. C just equals 2, and that's what they were asking us to find, and we said that. So a good idea would be just to check it. Okay, C is 2, that makes a tangent line. They look parallel to me. I'm pretty sure I did it right. Okay, this is the mean value theorem. Secant line, tangent line, they have the same slope, they're parallel, and that has to happen as long as you have continuity and differentiability on a closed interval. Okay? So let's turn and let's look at this, read this statement. You should tell me what you think of. I'm going to read it, and I want you to tell me what you're thinking of. Maybe it's something you remember from even maybe the first day of this class. In terms of rate of change, the MVT, mean value theorem, implies that there must be a point on the open interval, that just means in between your two endpoints, at which the instantaneous rate of change is equal to the average rate of change over the closed interval. What do you think? IROC equals AROC. For those of you that weren't in my class on the first day of school, this is what we talked about. Instantaneous rate of change and average rate of change. Remember the radar gun problem? Instantaneous rate of change is when the cop is pointing a radar gun at your car and they find your speed at that one instantaneous spot. Okay? Average rate of change should be overall what was your average speed. Your average speed probably is below the speed limit. Okay? But if your instantaneous speed isn't, you get a speeding ticket. All right. How many points do you need for IROC? 1 point. Okay, how many points do you need for AROC? 2. Okay, which one of these is the tangent line? IROC. That means AROC is secant. I'm just going to keep reviewing this because this is a concept we can build, and we can always bring it back to this. Makes it easier to understand, easier to remember. All right? So let's look at this plane problem. It says a plane begins its takeoff at 2 p.m. on a 2,500-mile flight. The plane arrives at its destination at 7:30 p.m. Explain why there are at least 2 times during the flight when the speed of the plane is 400 miles per hour. Okay, I'm going to back up to the first sentence. Before calculus, what is a question you might have been asked based off of the situation?
What is the average?
How fast was it going on average? You might even be asked to predict, take a model of this plane's speed, predict what was its speed at this point in time. And those are all things that you can do with your algebra skills. But really, this question, you have to relate calculus to it. Okay. So let's go ahead, though. If we're talking about mean value theorem, surely that's going to give us our answer. So let's go ahead and find our average rate of change. Okay, now this average rate of change is just like slope of the secant line. It's just the basic rate of change, no calculus involved. Okay, so what do I need to divide to get this rate? Yeah, 2,500 miles over 5.5, that's how many hours. And so, let's see how well I remember this. Anybody with a calculator want to back me up? Okay. All right, so this is our average speed. Again, this is not necessarily the max speed. It's not the speed all the time, but it's the average speed, okay? By mean value theorem, I'm already starting part of my explanation. What is something we know must be true by mean value theorem? Okay, so we know, let me back up and make sure, because I kind of asked a very open-ended question. So let's first of all say, can we use mean value theorem? Is the plane's speed and plane's path and all that, is that continuous?
Yeah.
Yeah, it can't not be. Is this differentiable? Could there be a cusp? Can the plane drastically change, like in one instance just change from one thing to the next? No, it's always going to be a smooth curve. Even if we think something's really drastic, if we were to zoom in on it, it would still be a curve. It would just be kind of a sharp curve. So we can definitely use mean value theorem. Now remember, mean value theorem means IROC equals AROC. So I already found the average rate of change. I know that overall, during this interval from 2 p.m. to 7:30 p.m., those are my endpoints, I know that the average rate of change, the slope of the secant line, is 454. I'll just call it that, because I'm going to use that number a lot. 454 miles per hour. What does mean value theorem tell me what else has to be 454? My instantaneous rate of change must be this at least once, okay? So by mean value theorem, I know that my instantaneous rate of change must be 454, and don't write as big as me because I'm writing way too big. At least once, because I really haven't answered the question yet, but I'm getting there. Okay, so I found the average speed. I figured out, I used mean value theorem appropriately, and I figured out that this plane, for sure, like if you learn to look at its speedometer, if you're the pilot, it's going to say that number at least once. Okay? So why, that's the calculus. Now let's use logic. Why does that mean there has to be at least 2 times during the flight when the plane of the speed of the plane is 400 miles per hour? What do you think?
It has to get there and then go back down.
Okay, so what is the plane's initial speed?
0.
0. Okay, what's the plane's final speed?
0.
0. So if the plane has to be going this fast at least once, and we have continuity, that's why continuity was really important. Okay, you can't just jump from 0 to 454. All right, so that means that the speed had to go from 0 through 400 to get to 454, and then back down to 0. Okay, and there's a lot of different ways to explain this. So I'm just going to write something here. I would say the plane starts at 0 miles per hour, accelerates to 454.545 miles per hour. Okay. And I didn't really need a comma then. And decelerates to 0 miles per hour. So the plane, I'm running out of room. The plane must have a speed, and I'm being very, very thorough here. Goodness. Lost anybody? Anybody stop writing? Miles per hour at least twice. And y'all just trust me, at least twice y'all write it. Okay, now as far as what exactly do we need to write? Do I really need to write all that? Okay, we're going to explore this, but I'm just telling you, on the calculus AP test, you don't want to be in the mindset, what's the least amount I can do to get all my points? Because you're going to eventually lose points doing that, okay? And I want you to be able to not only think about the answer, but be able to write it down. This is something, though, we are going to practice a lot. In fact, that AP Saturday on November 23rd, this is some of the stuff they're going to talk about, is like exactly on the AP test, what do you need to write to get those points, okay? And I'm going to teach you, we're going to move on for now, though. Okay, so now we are going to do example 4. I'm going to erase this so we have plenty of room. This is a totally different type of real-life example. And this is where we have this company, and this company is producing something. We don't know what it is. And somehow they figured out this weird equation represents how many units are sold, where T is the time in months. So if you notice, and we don't really know, is this the unit sold that month, or it's probably more likely the unit sold total. Okay, so as time goes on, maybe the market's saturated and they're not selling as many per month, and they're just leveling off, like everybody who wants to buy one has already bought one. Okay, so this A says find the average rate of change of S of T during the first year. You already know how to do this. This is an Algebra 2 level question, so I'm going to give you a minute to do this. And look back at previous problems if you need to. But I want you to answer part A on your own. All right, let's go over this. So, what was the first thing you did? Maybe anybody tell me something you did on your graph?
1 to 12.
So is it 1 to 12 or 0 to 12? 0 to 12. So I'm going to go 0 here and 12 here, and that's not a whole number, so that might cause me a problem. So, I have the point 0, 100, what was the y value for 12? Yeah, so let me show you, and I'm going to kind of do some calculator stuff here. So here's what, let me put it this. So I'm going to do 900, oh, no, not 900, 200, 5 minus 9 divided by, don't forget your parentheses here, 2 plus 12. I've been asked to show the calculator a little bit more in class, so I'm going to do some of that today. All right, and so you get 6,100 over 7. Now, if you do an estimation, okay, that's not too bad, but I'm going to tell you, we're about to use this number to do part B. Which one is more accurate? The first one, the fraction, okay? So I'm going to do 6,100 over 7. In my final answer, I can use the decimal. But if you're not quite there yet, if you're going to use this number, then you need to, you need to make sure it's accurate. So 6,100 over 7 minus 100 all over 12 minus 0. So again, I'm going to plug this into the calculator. So I already have, I'm going to go up and grab that fraction. Minus 100 divided by 12. And again, I get a fraction, 450 over 7. Okay, you can write 450 over 7, or you could diamond enter and get this. Okay, since this is my answer to part A, the decimal would be fine. I'm going to go ahead and still just use the fraction, because as long as your answer is accurate to 3 decimal places, you're good. All right, we do need to put units on this though. Okay, our Y was units sold per month. So that's your final answer. And if you wanted to use the that was a horrible box, but whatever, you get it. If you wanted to use the decimal, you could you always want to round to 3 decimal places. You will lose a point on the AP test if you round to 2 decimal places and your answer's not as accurate as they want it to be. Okay, so all of that, I don't know why I scrolled down yet, all of that to say what the slope of the secant line is, and this was algebra. We haven't really done any calculus yet. Part B is really asking you about mean value theorem without saying it. Just saying, when is the derivative equal to the average rate of change? When is the slope of the tangent line equal to the slope of the secant line? When are the 2 lines parallel? Now, you could probably look at this and guess that it's probably somewhere in here. Like if I had to draw a parallel line that's tangent, it's probably somewhere in here. That's not a bad idea to know and predict kind of what your answer is. All right, anybody tired of doing derivatives?
Yes.
Okay, so let's practice for now how to do a derivative in your calculator. Okay, so I'm going to remind you how to do this. Okay, if you don't know which menu button gives you what, just, oh, it wasn't that one. F2, let's try that. Nope, I don't see derivative here. Let's try F3. Now, if you forget, then just try it. F3, number 1 says differentiate. Okay, so I am going to differentiate my function, which was 200, parenthesis, 9 minus, oh, was it 5 minus? 5 minus 9 divided by, and since I'm going to divide by something that's not just one character, I need to put more parentheses in. 2 plus, and I'm just going to use x. Okay, I need to close the parentheses on my denominator. I need to close the parentheses in that thing after 200. Okay, and before I close the parentheses for good, I've got to do comma x. You will remember this if you practice it. Okay, you could do this derivative by hand. It's kind of messy, but you could do it. On a word problem where you get to use the calculator anyway, I've already told you, word problems you get to use the calculator. If you want to do this to save you some time and make sure you're not messing up on the derivative part, then do that. Okay, that's s prime of t. So let's write this down here. S prime of t equals 1800 over t plus 2 squared, or you could go 2 plus t squared, it doesn't really matter. And what we want to know is when is this equal to my average rate of change. So again, I don't want to use the decimal if I did that. Okay. Anybody want to solve this by hand? Not me either, right? But I don't have to. Okay, so let's go over how to do the solve. Okay, you need to do this on your after party. On the very last part E, I think is what it was called on the after party, you had to solve something that you cannot solve by hand. Okay, your calculator, remember, does this. So if you don't know where it is, then just try. It's not under F1, but look, when I press F2, I see solve. So we put that in. Now, if I already have this there, I'm going to go up and I'm going to press enter to grab it down here. And I want that to equal, now I can type 450 over 7, or if I'm really feeling lazy, I can come up here and I can grab 450 over 7 from there. I want to solve this equation, and before I in the parentheses, I've got to do the comma x thing. Okay, that tells me that I'm solving for x, not for something else. All right. And I get this. Okay? That's because they're trying to give me an exact answer. They did like quadratic formula or something. Yeah, I don't want an exact answer. At this point, I really do need an approximate because the question is during what month. So I'm going to do my diamond enter thing. And I get two numbers. One of them's positive, one of them's negative. Real world, and remember my interval is from 0 to 12. I can't include a negative number. So here's my answer. T equals 3.29. 29, what was that last one? 2915. We could say 292. Right, and this is in months. Okay, so you could say it's this many months after T equals 0, but if I say during what month?
Right.
What would you say during the
Third month.
Okay, so a lot of you are saying during March or during the third month. Watch this. If my answer had been point something, we would say that's during the 0th month. Okay, so from 0 to 1 would be January or the first month. From 1 to 2 would be the second month, or February. From 2 to 3 would be the third month, or March. So really, the third month, like this 3 point whatever, it's after 3 months already. So you could say during the 4th month or during April, okay? And that's kind of a weird thing, and I get that. All right, really, the answer that I have here is just as good, and it's not confusing, okay? But I just want to make sure we're good on when we say during what month, what that really means. And remember what I told you before, it's a good idea to check your work. Draw a little tangent line right here and see, do they even look parallel at all? Like, let's say you messed up and you thought that that -7 answer really meant +7. And you tried to draw a tangent line right here. Well, then you know, hey, I did something wrong. That can't be it. All right? It's not going to always figure out your mistakes, but it could on a lot of the time.